Okay, so the date on the opener says 4/16, but we're actually going to complete it today for 4/23. So you can scratch out the date if you want to, but you don't have to. So the first two parts of our opener says find the greatest common factor of the terms in the following expressions. How many terms does this first expression have? Three. Good. So it has three terms, so we're going to go through and we're going to factor the three terms. So what are my factors for 54?
5 and 9.
How about 6 and 9?
Oh, yeah, 6 and 9.
Okay, finish up 54 for me, Daisha.
2 and 3. And 3 and 3.
Okay. For 36, David?
6 and 6.
Keep going.
3 and 2.
Same thing. Danier, for 90?
10 and 9.
Okay.
Then 3 and 3. Then 5 and 2.
Okay. So after I make my factor tree for each one of these, I'm going to come over and I'm going to write them out in a list. So I'm going to write 54, 36, and 90. So Daisha, what are my factors for 54? What are my prime numbers for 54?
2 times 3 times 3 times 3.
David, for 36?
Yeah, negative 36.
That negative doesn't matter right now. It only matters when we're doing the area.
2 and 3.
Remember, we're going to put them in order from least to greatest, right? He went to the restroom real fast. And then for 90, Danier?
2 and then 3.
And then, okay. Now what do I do?
You find a common.
Yeah, I circle what they have in common. So what number do all three of my terms have in common?
2,
Okay, so they have 2's in common. Okay.
3.
Okay, they have a 3 in common.
That's it, man.
Nah.
Wait, what?
What else do they have in common? Another 3, yeah. Okay. So what am I going to multiply together then to get my greatest common factor?
2 times 3.
So, as AJ said, 2 times 3 times 3. So what's 2 times 3? Times 3? 18. Okay, so the number part of my greatest common factor is 18. But I'm not done because I have to go back and check with my variables. Do they all have an x?
Yep.
Which one do I pick?
The 2.
The x squared, because I'm going to pick the one with the smallest exponent. Do they all have a y? Okay, which one do I pick?
2. That means the 3.
The y to the third power? Do they all have a z?
Yep.
Which one do I pick?
4.
And that's my greatest common factor. Whoops. Now, when we find the greatest common factor of our terms, what does this end up being from our lesson yesterday? The greatest common factor ends up representing our, what on our area model? Height. Good. Okay, let's look at the bottom one now. How many terms am I going to have to find the greatest common factor for in this expression? How many terms?
3. No, 2.
I mean, you said 4, 3, and 2. 2. Good. All right, AJ, what are your factors for 450?
9 and 50.
Okay, keep going.
9 is 3, 3. For 5, no, for 50 is 10 and 5. And then for 10 is 2.
Kaylon for 300.
10 and 30.
Okay.
Then you do a 2 and 5. Then you do 3 and 10. Then you do 2 and 5.
What do I do now? What do I do next?
You
you come to the side and you write them out.
Yeah. So I make my list. I come over to the side. AJ, what are your factors for 450, your prime numbers? In order from least to greatest?
2, 3, 3, 5, 5.
And Kalon for 300?
2, 3, 5, 5.
And what do they have in common? Jaden?
The 5.
Okay, we have 5 in common. What else?
Another 5.
Okay. What else?
Another 3.
What else?
Another
Anything else? All right. So greatest common factor is going to be 2 times 3 times 5 times 5, which is going to equal. Okay, I think I know what it is. Somebody check my math though. So 2 times 3 times 5 times 5.
That's gonna be 30, that's gonna be 150.
150? That's what I came up with. Am I done?
Nope.
Nope.
You gotta go find the
My variables, okay? Which, do they both have an x?
Yep.
How many do they have in common?
2.
Do they both have a y?
Yep.
How many do they have in common?
2.
So there's our final answer. So the greatest common factor for the two terms are 150 x squared y squared. And again, as what we learned yesterday, the greatest common factor is going to represent the height of our area model. So that's some of the new information that we learned yesterday. Give you guys 30 more seconds to get it down.
Hurry.
You should have it. I know. If you are done, flip it over to the back. The back is what we learned yesterday. Okay, so if you're finished, flip it over. Start working through the back. See how far you can get on it.
If we talk, we don't never talk.
Wait, what?
No, we talking about validation.
Okay. Okay. The back side says, use the rectangular model to factor the expression using the GCF. Basically, you use the GCF that you found on the front. So, who has their opener on the front side? So, the GCF for 54, 36, and 90. 54, 36, and 90. That was our first one that we did. What did that equal?
18, x to the second, y to the third.
So we had 18 x squared y to the third x. Woo.
Wait, no, I thought it was the second.
X squared y to the third z to the what? Fourth. Okay. So usually now, if we didn't already find the greatest common factor for these three terms, we have to factor tree and find the greatest common factor. Now, we look at our area model and we fill in the information that we know. So with the greatest common factor and these three terms, what do I know about my area model?
That is 18.
With these numbers that's listed above here, with my greatest common factor and my three terms, what do those represent on my area model?
The
Let me simplify it. What's the greatest common factor represent?
height.
The height. So that's going to come out to the left of my area model. So that's my height. So I have 18. Okay. And then what do my three terms represent?
They don't want the bottom of that.
Which is the what?
The area.
The area. So my first area is,
64.
why wouldn't it be my height and my width? How do I know automatically?
Because
That-
you don't have it with you. You got to solve for it.
Well, it doesn't have the what? Parentheses. Good. What's my second area?
36.
Nope.
Negative.
-36. That's when we worry about that negative, Kaylon. And the last one.
90.
So if I know the height and I know the total area, I need to find the what? The width. Okay? So I'm going to go ahead and start up my work. So I'm going to go ahead and put my height in each rectangle. Bless you. So that I can find my width. So I like just to go through, get as much of my work written out as I can right away so that I don't forget to write it in later. So what I'm doing is, because I know each height of the rectangle, I'm just writing that in now. Remember, the height is what my greatest common factor was. Okay, so I have the areas, I have the heights, so now I'm ready to find the width of each section. So when I go to find the width of each section, I have to think 18 times what gets me to 54. If you don't remember, flip your sheet over to the front side. Do me a favor, everybody just quickly flip their sheet over to the front side.
I know what she
Now
did.
find where your 54 is. What number didn't we use?
4.
What number did we use for 54?
3.
3. So if I take 18 times 3, will that get me to 54? Yeah. So 3. How many more x's do I need for my width? 1. Oops. Put that in the wrong one, didn't I? So 3. I need 1 more x. What about for y's? Do I need any more y's?
No.
Do I need any more z's?
No.
No. So the width of this first rectangle is 3x. Okay? Now, we're ready to find the width of the second rectangle. So flip your sheet back to the front. Where we did our factor, or where we listed all of our prime factors out, what number did we not circle for 18? Oh, slacker. 2. So 18 times 2 will get me to 36. But what type of 36 is that? So what does that 2 need to be? A negative. Good. Do I need any more x's for my width? No? Do I need any y's?
Wait. Yeah.
Yeah, how many? And then do I need any z's? No. So the width of my second rectangle is what?
Negative 2.
-2y's. Jaden,
Negative 2.
when I said, do I need any z's, it made me think of you and sleeping yesterday. All right, last one. So again, flip your sheet over to the front side. Look where we listed out our numbers for 18, or excuse me, for 90. Which number did I not use? 5. So 18 times 5, does that equal 90? Yup. So now we worry about our variables.
It's not gonna be a Z.
Do I need any x's?
No.
Any y's?
No.
Any z's?
Yes.
How many? So the width of my third rectangle is,
5.
am I done with this yet?
Yeah.
Oh, not yet. Because remember, my first 3 terms, or my first part of my expression, is the area. The area of a rectangle is area equals height times width. So now we need to write out my height and my width. So what's the height?
18. 8.
So I'm going to write that right next to my equal sign. How do I show that I'm taking my height times my width? Then what?
3. 8. Negative 2y. Plus 5.
Nice, Stacia. Almost there.
Another 3.
And that's it. That's what our lesson was yesterday, using the greatest common factor to factor the area model.